Good morning! It's March 6th, and this is your daily brief in science. Here's everything you need to know. A careful look at asteroid 2024 YR4 shows it poses no threat to Earth or the Moon, after refined orbits reduced any collision risk to zero. NASA, using data from the Webb Space Telescope in February, confirmed there is zero chance of a lunar collision in 2032. Early assessments had suggested a small chance of lunar impact in December 2032, but new measurements eliminate that likelihood. The finding highlights ongoing vigilance in planetary defense and underscores international collaboration among Johns Hopkins APL, JWST engineers, ESA's GAIA mission, and NASA's CNEOSOC. Led by a Johns Hopkins APL team, Webb observations represent some of the faintest asteroid observations to date and demonstrate Webb's role in tracking small bodies. The study shows how improved infrared observations can dramatically alter risk assessments for near-Earth objects and inform planetary defense strategies. Timely infrared data from JWST enabled rapid assessment and would have constrained mitigation options for a potential lunar impact if observations had lagged. The result shifts the narrative from a terrestrial threat focus to confirmation of a safe trajectory, evidencing advances in data integration from multiple space observatories and long-term monitoring. The episode reinforces readiness in planetary defense and supports science-driven journalism and public science funding. Confirmation relied on new James Webb Space Telescope near-infrared camera observations coordinated by an international team. CNEOSOC at JPL updated the risk assessment as new data arrived, illustrating how risk models improve with additional observational input. Experts emphasize balancing warning and reassurance in planetary defense communications, noting some may be disappointed by the lack of dramatic lunar effects. A team using atom manipulation tools has created a novel C13Cal2 molecule with a half-Mobius electron topology, a topology not seen in chemistry before. Researchers from Manchester, Oxford, Regensburg, Lausanne, and IBM Research Europe assembled the molecule on a gold surface at cryogenic temperatures and precisely shaped its topology with atomic force microscopy and scanning tunneling microscopy, mapping the electron distributions along the way. The molecule starts as a fully chlorinated C13Cl10 ring, from which chlorine atoms are selectively removed to produce the half-Mobius topology, revealing a corkscrew-like electronic structure that twists 90 degrees per circuit and requires 4 loops to return to the starting phase. This topology can be reversibly switched among clockwise twisted, counterclockwise twisted, and untwisted states, demonstrating controllable electronic topology in a single molecule. AFM and STM confirmed the half-Mobius geometry and showed a twisted, lowest unoccupied molecular orbital in the half-Mobius singlet state, versus a planar untwisted orbital in the triplet state. Bias voltage control via the microscope tip enables shifting among left-handed half-Mobius, right-handed half-Mobius, and planar configurations, illustrating topology switching on demand. A small electromagnetic pulse further demonstrated controllable topology, enabling reversible switching between twisted and untwisted states. Quantum computing played a central role in validating the electronic configuration and topology, with simulations run on conventional computers and IBM's quantum processor to understand the system. The work highlights 2 advances: engineered electronic topology in chemistry and practical quantum simulations that tackle molecular-scale systems beyond classical capabilities. Hybrid quantum classical workflows and 72-qubit quantum calculations capture deeply entangled electron interactions and the helical pseudo-John Teller effect driving the topology. The half-Mobius topology imposes unique boundary conditions and Barry phase characteristics that could influence magnetic, electronic, and spin-dependent properties. Looking ahead, the study points to prospects for more complex topology-switchable molecules and networks, expanding topology-driven chemistry. A new study warns Europe's forests could face more disturbances from fires, storms, and pests as the century progresses, potentially doubling in severe warming scenarios. The AI-based model, trained on 135 million data points from 13,000 European locations and supported by several decades of satellite data, analyzes disturbances at a hectare level to show regional differences. Southern and Western Europe are projected to see the strongest changes, while Northern Europe may have fewer overall impacts but with hotspots. The authors call for a multifaceted response, cutting greenhouse gas emissions and managing forests to boost resilience against climate extremes, including how forest practices can strengthen resistance to future stressors. Reduced forest carbon uptake is expected as damages rise, increasing the pressure on other sectors to accelerate emissions reductions. The findings stress that forest policy and management must prepare for more disturbances, buffer service fluctuations, and explore climate-resilient forests that can recover and adapt to changing disturbance regimes. Researchers advocate integrating rising disturbance levels into policy and management, supported by new scientific methods, to mitigate risks and seize opportunities for climate-resilient forest futures. Disturbances affect carbon storage, timber supply, and wildlife habitat, necessitating adaptive forest management that buffers services and leverages disturbances for climate-resilient restoration. Massive reforestation could help sequester carbon, but future forests may absorb less CO2 as warming continues, and dead trees may release stored CO2, potentially turning forests from sinks into sources if fires or pests kill standing timber. Disturbances shift forest structure toward younger stands, reducing mature carbon storage and altering habitats, weakening Europe's forest carbon sink and resilience. The report advocates for mixed species forests to diversify risk and reduce vulnerability to pests and climate shocks, with ongoing trials to identify effective species combinations. A new look at wastewater shows human metapneumovirus, or HMPV, surfacing at higher levels in parts of California, including Merced, Novato, and Sunnyvale, with cases also detected in Los Angeles County. There is no vaccine or specific antiviral treatment for HMPV, and diagnosis requires laboratory testing. Most people recover with rest and fluids, but some cases may require hospital care with supportive measures like oxygen, anti-inflammatory steroids, or intravenous fluids. HMPV is causing cases in states such as California and New Jersey, and care remains supportive and focused on symptoms. The reporting credits go to Fernando Cervantes Jr. of USA Today. Experts say prior exposure to common respiratory viruses provided some natural immunity before the pandemic, but immunity waned during periods of reduced social contact, contributing to renewed circulation as activities resumed. CDC prevention guidance emphasizes regular hand washing, cleaning surfaces, staying home when ill, and reducing transmission via direct contact, sneezing, coughing, or contaminated surfaces. Prevention also focuses on avoiding touching the face, keeping distance from sick individuals, and reducing exposure to infected droplets. Additional CDC recommendations include thorough hand washing, avoiding face touching, staying away from the sick, cleaning frequently touched surfaces, improving indoor air quality, and covering coughs or sneezes. HMPV was first identified in 2001 but has circulated since the 1970s, and ongoing surveillance highlights its public health impact and potential for co-infection with other respiratory viruses. Wastewater Scan analyzes sewage samples to detect infectious diseases and inform public health responses at multiple levels. Symptoms are hard to distinguish from other respiratory illnesses. Diagnosis relies on medical tests to differentiate HMPV from flu or COVID-19, which have their own antivirals. Nationally, HMPV cases have been trending up since late 2025, with the virus typically circulating in winter and spring and contributing a notable share of respiratory infections during late winter to early spring. AntScan is changing how we study ants, using a synchrotron-powered CT pipeline to generate roughly 3,000 images per scan and produce hundreds of three-dimensional models of ants. Led by Evan Economo at the University of Maryland with KIT collaborators, the project combines high-throughput workflow, robotics, and AI to digitize 800 ant species into interactive three-dimensional models. The resulting models reveal internal anatomy, muscles, nervous and digestive systems, and stingers at micrometer resolution, with raw data and an integrated viewer openly accessible. All raw data are openly available, and an online viewer lets users explore each model, democratizing access to high-resolution morphological data for researchers, educators, and artists. AntScan aims to create an open-access library of raw three-dimensional data and visualization tools to accelerate discovery and cross-disciplinary collaboration in biology, morphology, and education. The Nature Methods paper presents AntScan as a blueprint for large-scale quantification of organismal form and discusses its implications for biodiversity research. Economo envisions broad applications of digitized biodiversity data, from labs and classrooms to Hollywood, and plans to expand specimen scanning while continuing AI work with UMD students. The project's workflow outlines how high-throughput data can transform the study of morphology at scale. AI-driven pose estimation is being developed to convert contorted scan poses into lifelike poses, enhancing realism for research, education, and entertainment. AntScan stands as a transformative, interdisciplinary effort to digitize global ant biodiversity with broad implications for science, education, and media. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.